The journey of the Voyager 1 spacecraft, launched in 1977, began with cautious expectations, with early assessments warning that it might only capture faint images unless modifications were made to its systems. This underscored the humbling nature of space exploration, especially when compared to the vast, uncharted expanse of space. Now, after more than 45 years of navigating the cosmos, Voyager 1, currently located 224 billion kilometers from Earth, has sent back data that has puzzled scientists. In this exploration, we delve into the mysteries surrounding Voyager 1's latest anomalies. Are we nearing a loss of communication, or could extraterrestrial interference be at play? To understand the significance of these strange signals, we first need to examine Voyager 1's remarkable journey. Originally, the Voyager missions were designed for a 5-year mission to explore Jupiter and Saturn. However, both Voyager 1 and its twin Voyager 2 exceeded these expectations, providing groundbreaking data. Voyager 2 even delivered humanity's first close-up images of Uranus and Neptune, achieving a historic milestone in space exploration. In 2012, Voyager 1 achieved a major milestone by entering interstellar space, a feat confirmed by NASA in 2013. Upon reaching this uncharted territory, the spacecraft encountered a realm filled with constant flows of particles and magnetic fields, unlike anything previously observed. Voyager 2 followed in 2018, solidifying the spacecraft's legacy as symbols of human ingenuity. Now situated 177 billion kilometers from the Sun, Voyager 1 continues its mission, expanding our understanding of space. These missions have reshaped our perception of space, revealing the interactions between solar winds and the interstellar medium and providing insight into the heliosphere's nature. The Voyager missions have not only broadened our knowledge but have also captured the human imagination, representing a lasting legacy of space exploration. As for the possibility of contact with extraterrestrial life, researchers speculate that the first encounter could occur as soon as 2029. It is believed that messages sent via Voyager 1 could potentially reach intelligent lifeforms by that time, marking a monumental moment in human history and sparking global curiosity about the implications of such an encounter. Voyager 1's enduring success is a testament to its robust design. Despite the harsh conditions of space, intense radiation, extreme temperatures, and the constant threat of micrometeorite impacts, the spacecraft has continued its mission for over 46 years. This achievement is a tribute to the brilliant engineers and scientists who ensured the spacecraft was built to withstand these challenges. At the core of Voyager 1's longevity is its power source, a set of radioisotope thermoelectric generators, RTGs. Unlike conventional batteries, RTGs convert heat from the natural decay of plutonium into electricity, providing power to Voyager 1's instruments. Although the output of the RTGs has decreased over time due to radioactive decay, they still supply enough energy to keep the spacecraft's scientific instruments operational. Voyager 1 is not just a spacecraft, it's a highly sophisticated scientific tool. Equipped with instruments like the Cosmic Ray Subsystem, CRS, High-Gain Antenna, Imaging Science Subsystem, ISS, and various others, it has made significant contributions to our understanding of space. Voyager 1 has provided detailed images and data about Jupiter's atmosphere, Saturn's rings, and even detected volcanic activity on Jupiter's moon Io. It has also studied cosmic rays, magnetic fields, and plasma waves, all while traveling through the vast emptiness of space. One of Voyager 1's most extraordinary features is the Golden Record, a 12-inch gold-plated copper disc containing sounds and images meant to represent Earth and humanity. This record serves as humanity's message to any potential extraterrestrial civilization that might encounter it. It holds a selection of 116 images and sounds, including music from various cultures, greetings in 55 languages, and the unfiltered sounds of nature, such as thunder and bird songs. The Golden Record is a symbolic attempt to bridge the gap between civilizations, separated by the immense distances of space. The eerie calls of whales, each component meticulously chosen by a council led by the esteemed astrophysicist Carl Sagan, embody a message for the future. This message, encoded on the Golden Record, is shared by the Voyager spacecraft, particularly Voyager 1, alongside its twin Voyager 2. The thought that these explorers could carry a message from Earth, potentially discovered by extraterrestrial life in the distant future, is a fascinating possibility. If an advanced extraterrestrial civilization were to come across Voyager 1 and retrieve the golden record, it would mark a momentous event in the history of interstellar communication. 3 potential outcomes could unfold. First, the extraterrestrial civilization might use their advanced technology to decode the data encoded on the record, both visual and auditory. If they had the means for interstellar travel or communication, scientists speculate that they could send a response to Earth, possibly reaching us by 2029. Alternatively, they might opt not to engage with Voyager 1 but instead treat it as a historical artifact, adhering to the principle of non-interference with the development of other civilizations, a concept explored in numerous science fiction stories. Regardless of the outcome, an encounter with extraterrestrial life would be an earth-shattering event for humanity. However, Voyager 1, despite its long and dedicated service, has recently introduced an element of intrigue. It has begun transmitting puzzling data from the farthest reaches of interstellar space, leaving NASA scientists in a state of confusion. This anomaly originates from a critical onboard system known as the Attitude and Articulation Control System, AACS, which is responsible for measuring, reporting, and adjusting the spacecraft's position in the vastness of space. The system ensures the antenna remains aligned with Earth for communication and data transmission. Yet, inexplicably, the AACS is providing data that contradicts the spacecraft's actual movement and trajectory. This raises the possibility that Voyager 1 has become confused about its position in the cosmic void. NASA's evaluation of the situation is reassuring yet perplexing. Despite the incorrect data from the AACS, Voyager 1 continues to function normally. It dutifully receives commands from mission control and gathers valuable scientific information from its remote location. The spacecraft remains undisturbed by the anomaly, and no onboard protective systems have been triggered, systems that would normally place the spacecraft in a safe mode to prevent damage. Interestingly, the communication signal from Voyager 1 remains robust, an unwavering beacon in the void, with its high-gain antenna steadfastly pointing toward Earth. Yet the mystery deepens, as the telemetry data sent by the AACS appears to be generated randomly or, at times, defies logical interpretation. Suzanne Dodd, the mission manager for both Voyager 1 and Voyager 2, sheds light on this perplexing situation. She suggests that such mysteries are not entirely unexpected in the twilight years of the Voyager mission. These spacecraft, now well beyond their expected lifespans, have traveled farther and for longer than anyone initially imagined. They have crossed into interstellar space, a harsh, high-radiation environment, an unknown realm where no spacecraft has ventured before. While the engineering team faces a challenging puzzle, they remain optimistic about resolving the issue with the AACS. If they can pinpoint the source of the problem, it might be fixable through software adjustments or by utilizing backup systems. It's worth noting that Voyager 1 has encountered similar issues in the past. In 2017, its primary engines showed signs of wear, prompting engineers to switch to backup engines that hadn't been used in years during the spacecraft's planetary missions. But now a new twist has emerged. NASA's clever engineers have identified the issue. The AACS was transmitting telemetry data to a computer that had long since failed. This corrupted the data, and the mission team suspected this as the cause of the anomaly. They continued their risky approach by repeatedly instructing the AACS to send data to the correct computer, even as they remained uncertain about why the AACS had been misdirected. If this theory proves correct, it suggests that an underlying issue with another onboard computer may have triggered the anomaly. Despite these uncertainties, the team is focused on uncovering the root cause of the problem, even though they believe it does not pose a serious threat to Voyager 1's overall health. Still, understanding the spacecraft's internal workings better remains a priority. As we consider the question of how much longer Voyager 1 can continue its incredible journey through the cosmos, the answer remains uncertain. However, it's clear that time is running out for this intrepid explorer. Before we dive into this pressing question, it's essential to understand how Voyager 1 manages to communicate with us from such an unimaginable distance. Explorer 1's journey into the vastness of space presents a complex challenge, as its communication with Earth is heavily reliant on an advanced radio system designed to function efficiently both within and beyond our solar system's boundaries. At the heart of this system is the spacecraft's powerful 3.7-meter high-gain antenna, HGA, a critical component for sending and receiving radio waves. These communications are facilitated by the Deep Space Network, DSN, a global network of 3 Earth-based stations equipped with large antennas to ensure reliable communication. Explorer 1 typically communicates with Earth through DSN Channel 18, utilizing frequencies of either 2.3 GHz or 8.4 GHz. When sending signals back to Earth, the spacecraft uses a frequency of 2.1 GHz. This advanced setup allows Explorer 1 to maintain contact even as it ventures further into the unknown. However, as the spacecraft moves farther away, direct communication with Earth becomes increasingly difficult. To overcome this, Explorer 1 is equipped with a digital tape recorder, DTR, capable of storing about 67 megabytes of data, which can be transmitted back to Earth at a later time when conditions allow. By 2023, it takes more than 22 hours for signals from Explorer 1 to reach Earth, a stark contrast to the 15 minutes it takes for Mars rovers to communicate. The spacecraft began its journey transmitting a 20-watt signal, but as it travels through space, the signal weakens, making it more challenging to maintain communication. Despite this, the strength of the signal is not the main issue. Rather, the focus is on having sensitive receivers capable of detecting these faint signals. NASA's Deep Space Network, composed of large 70-meter antennas and smaller 34-meter ones located around the world, plays a crucial role in picking up these weak signals. Through advanced technology and careful monitoring, the DSN can detect signals that are thousands of times weaker than an FM radio transmission. These stations work around the clock, ensuring that communication with Explorer 1 continues as long as possible. In theory, there is no practical limit to how far we can extend our communication with distant spacecraft, provided we have sensitive and precise equipment to capture these faint signals. Yet, the reality is that as Explorer 1 moves further away from Earth, maintaining communication becomes increasingly difficult, with data transmission rates slowing down. While the spacecraft's journey may have no defined endpoint, its ability to send and receive data will eventually reach a point where contact is no longer feasible. The key limiting factor is Explorer 1's energy. The spacecraft relies on 3 radioisotope thermoelectric generators, RTGs, that convert heat from the decay of plutonium-238 into electrical power. However, as the plutonium decays, the RTG's output will decrease, eventually leading to power failure. Over time, Explorer 1 will progressively shut down non-essential systems to conserve energy, focusing only on communication and critical scientific instruments. By 2025, the spacecraft will celebrate its 50th anniversary, a remarkable achievement for any spacecraft. However, this milestone also marks the beginning of the end for its mission. As the spacecraft continues its journey, it moves closer to the end of its mission, a mission that has revolutionized our understanding of the universe and inspired countless scientists and explorers. As we bid farewell to this trailblazing spacecraft, we celebrate its enduring legacy, reminding us of the bravery, curiosity, and wonder that have driven humanity to explore the unknown. Explorer may first be a small spacecraft in the vastness of space, but its impact on humanity is immeasurable. It has expanded our horizons, sparked our imaginations, and deepened our sense of awe. As it drifts further into the unknown, it carries with it the hopes, dreams, and aspirations of humanity, a testament to our unyielding spirit of exploration. The story of Explorer 1 is not just about a spacecraft. It is a reflection of ourselves, our courage, curiosity, and the timeless quest for knowledge. And although Explorer may first one day fall silent, its message will live on, a symbol of the enduring spirit of exploration that transcends the boundaries of existence.